I'm excited to kick off another series of conversations. This time, I get to sit down with some really smart people who spend their days thinking about sustainability and ask them to help me better understand the technologies, the ideas, the innovations that are helping create a more sustainable world. And what better way to start than to be joined by my guest today, Szymon Slupik. Szymon is the CTO and co-founder of Silvair, a provider of lighting control platforms that help transform lighting systems into intelligent building infrastructure. He's also the chair of the Bluetooth SIG Mesh Working Group. When Bluetooth Mesh Networking was still an idea on a whiteboard, it was probably Szymon who was holding the marker. And through his work with lighting controls, building systems, and industry standards, he brings a really unique perspective on how connectivity can help organizations operate more sustainably at scale. Szymon, welcome. Thank you for doing this. It's great to have you here.
Yeah, thanks for having me. Looking forward to this conversation.
Before we get to the serious business of making buildings more sustainable, we like to kick things off with just a kind of playful "would you rather" question, just to learn a little more about you and loosen up. Are you game?
Yeah, sure. Let's try.
Would you rather be required to strike a superhero pose, have confetti shoot from your sleeves, or snap and spin and point like you're in a music video every time you connect to Bluetooth?
Oh, the last one, of course. I mean, Bluetooth connections, it's that there's magic there. And, over the years, we've brought that to the point that they are invisible. I mean, so many people use them so widely, and that just happens in the background.
I love that answer. Like you said, though, it's those connections are everywhere. You'd be snapping and spinning a lot. You might actually end up getting pretty dizzy through that whole thing.
Yeah, sure. Definitely, it's even difficult to count them in absolute terms. They are everywhere. I mean, people don't even realize.
Let's talk about lighting. So you've spent a big chunk of your career working in lighting control in commercial buildings. When most people think about sustainability, they might not immediately think about lighting. Why should they?
Well, there are obvious reasons and there are less obvious reasons. So the obvious reasons is the basic function of lighting control is turning off lights when they are not needed. Period. I mean, it took me a couple of years to realize that and, have this single sentence description of like what you're doing. We turn off lights, or our software turns the lights off. That's the energy part, of course. You turn off lights, you use less energy. But also when you turn off lights, you prolong the life of the lights. And not many people initially get that point. And it's a huge saver. It can save you so much on upgrade costs and operating costs. Every device has a rated lifetime. So if you can simply extend that lifetime, but not pushing all the time, so to speak, pedal to the metal, like 100% output and 24/7, just shutting it down or dimming it down, the load is lighter. It wears less. It works longer.
Reducing energy consumption through lighting control is a powerful story on its own, but the lighting network in buildings is becoming something more than a lighting system. Lighting and HVAC are more connected than many people might realize. Walk us through how data from a lighting network can help HVAC systems operate more intelligently, and what impact that can also have on energy consumption and sustainability.
It was kind of obvious that people started many years ago replacing legacy lights with LED lights. And people have been doing that across the globe on a massive scale. There's so much motivation to do that alone. Now, if you are replacing the lights, adding a small sensor to every light is a little additional cost, and that enables a complete new universe of opportunities. Because, but the important part is that is just adding a sensor, not adding additional wires between the lights for sensors to communicate. So if we can do it all wirelessly, but just add a little sensor to the light, then do this replacement operation, and then you end up with dense grid of sensors. So this is why basically the goal here is to have more sensors. That's the long-term idea. Sensors for mostly everything. This has been the idea of making this sensory information available to other subsystems in buildings like heating and ventilation and air conditioning. And there's been work mostly pioneered by the American standards organizations like ASHRAE and the policymakers like Design Lights Consortium. And that's kind of prompted us to work closely with them and develop this, what we call now the HVAC integration NLC profile spec. That went out about a year ago, and it basically defines the interoperable data format for wireless information exchange over Bluetooth. And it means that you can start making wall thermostats that simply understand the occupancy information in their zones, in their rooms where they are mounted. So you don't require any complex, installing additional sensors for HVAC or programming the logic to translate the lighting sensor information to HVAC sensor information. We just standardize the language between them.
The other opportunity that comes about from this idea that lighting can be, just a building-wide data grid is, helping organizations or operations understand the actual condition of the systems and the equipment that they're operating. I'd love for you to talk a little bit about predictive maintenance and the benefits that come, the sustainability benefits, also the operational benefits that come along when maintenance can become proactive.
Yeah, very, very good point. This is, I would say, the next step in wireless data in buildings. Once you install the lights, then the next thing you can start doing is, checking whether the lights are pinging you back. Are they alive or not? So it's a very simple way of, you can build a very simple logic on top of that, saying, hey, this light is dead. Go and replace it. But that's just the beginning. On that front, we worked very closely between Bluetooth SIG and DALI Alliance, because DALI has this great concept of D4I data, and they define close to 100 data points that every D4I driver has to implement and make available. Now, the role of Bluetooth is to harvest that information and make it available to the reporting system. And this has been the fruit of that joint work has been the DALI Part 341, which is the DALI to Bluetooth interface specification. These are the foundational blocks such that, we can see proliferation of interoperable products, both from Bluetooth side and the DALI side, that simply combine together. And as I said, so many data points about maintenance. So, of course, immediately you can extend your maintenance management systems, not only by checking whether the device is responding back or not. You can check how it is working. Is it at the edge of its performance limits, or is it treated lightly, or are there any external conditions like voltage spikes? And when you, as I said, operate them lightly, the practical lifetime can be extended by multiples. So without this data, say a driver is rated for, 30,000 hours. I mean, you start the clock and you run for 30,000 hours, and then you go and replace the drivers. Now, some of them may still have a lot of life in them. Now, without the data, you don't know. So the whole concept of predictive maintenance is, first of all, like spot the issues and spot the problems even before they become critical. If you have a warehouse and you have strong high bay lights and they don't run 100% all the time because there are sensors and they are dimmed down and turned off, and the wear and tear is much lower. So you can simply check the counters and say, hey, this light has just traveled through 20% of its rated lifetime, not 100%. So it can live for the next 5 years or longer. The facility manager can decide to postpone the replacement because the devices are still in very good condition. And there are savings on many fronts. So this is the value of this data is really something. And then of course, like in the end, there's this human experience. Like you expect good light. So if you can proactively monitor the data and through that provide good lighting, that's the value.
And I'm curious too if you could share. Have you seen a case study where the data revealed that equipment still had significant useful life left, even though maybe the traditional maintenance schedule would have said, hey, it's time to replace it? Can you share maybe a case where you've seen that play out with a customer?
Yes, so I cannot name the customer, but the bigger the portfolio of facilities they manage, the more important that becomes. So think of large box retailer stores and the whole network of them. So how many Home Depots you have in the country or other brands, and then multiply that by the number of lights you have in each store, and then this is the value of this maintenance data that you're collecting. I mean, first of all, you can provide good user experience, but then because those lights are not operating at a fixed output, they are dimmed, they are turned off based on the behavior of occupants of the facilities, and then on that scale it becomes absolutely obvious that even if you do not replace the light fixtures prematurely, your gains are absolutely obvious.
And that it really helps illustrate how sustainability isn't only about consuming less energy. It's about getting more life from the systems that we've already deployed.
Yeah, so in one sense, you can also call it reduced consumption, but it's not the consumption of energy itself. It's the consumption of goods in general. So, to me personally, sustainability is about reducing consumption. But it's not only about, using less gasoline or using less electricity. It's personally, I'm really big fan of maintaining devices in good working conditions for long periods of time. And of course, on the industrial scale, that only can be done if you see the data of how they operate. And that also helps you because some devices may be not adequately designed to the environment they work in. So you may see patterns, like especially larger scale, you may see patterns that show you, okay, this light type is having more problems than the other light type because it is exposed to sunlight or low temperatures or something else, vibrations, whatever, and it may improve the product design to improve the lifetime, and that is reduced consumption as well. On the large scale, bits do not cost. I mean, main cause these atoms, the physical things. And so, and data is bits. So if you can capture the bits through the wireless infrastructure and simply look at the data and see, okay, there's still life in those atoms. That's the large scale gain.
Yeah, extending life cycles of devices, systems. It's such a powerful lever for sustainability. I actually want to talk about something else that's gaining a lot of interest right now, and that's battery-free devices. So, can you share a little bit about why you view battery-free operation as really an important breakthrough?
One very simple example is we have those Bluetooth wireless energy harvesting wall switches that can power themselves and send wireless messages, Bluetooth messages over the air, basically forever. It feels like magic. Like people's reaction to this device is always like, can't believe this works, because looks like a piece of plastic, but inside typically you have a small energy harvesting engine, which is a magnet moving in a coil or something similar, or a photovoltaic cell at different sources of energy. The point is that Bluetooth low energy, as the name implies, it really uses very little energy. And that allows to build such highly abundant fleet of devices that can power themselves. And that's this magical part. And you can say they are truly wireless. We are not there with lights yet. I mean, lights require power because they require power to produce the light output. But switch and also sensors, you can have them in energy harvesting variants, and this is the beauty of the technology. That basically they live forever. They are maintenance free. I think some of those devices are certified for up to, say, 1 million clicks. So I don't know how many years is that 1 million clicks, but they probably will outlive both of us. So,
Yeah.
It's magical, and it just works, and they sell in numbers, and they solve so many problems in such a beautiful way because of Bluetooth.
Of course, none of this happens at scale if systems can't work together. Can you talk a little bit more about the importance and the significant role that global, open, interoperable standards will play and are playing in solving sustainability challenges?
I'm a very strong believer in open standardization, and it's not an easy task because it forbids people from taking different shortcuts. It basically mandates them to do certain things as they are defined. But so that makes life harder for manufacturers. But that makes the market so much bigger for the customers, because interoperability means that they can source anything from anyone, and those things will work together. So it's a really great promise and great aspect of interoperable systems. People want to buy things with the promise or even guarantee that they will work together, and that's the role of the standards. And then this makes this whole investment the investment decisions so much easier for the facility managers and building owners.
Where do you see the biggest sustainability opportunity over the next decade or so?
Well, definitely, I can speak subjectively from my own and my company perspective, and this is enabling existing buildings with dense infrastructure of sensors. And we talked about lighting sensors and how they ended up being there through the LEDification and lighting retrofits. Assuming we have Bluetooth mesh network in the ceiling already, you can start adding different types of sensors. And some sensors may be embedded in the light fixtures in the ceiling, but not every parameter you can measure in the ceiling. So many sensors will end up being at the shoulder level on walls or on desks, and a variety of implementations. We talked about energy harvesting aspects, so many sensors can be built as energy harvesting sensors, even for indoor use. There is good progress in light harvesting panels for indoor use. So tiny panels that can produce good amount of energy when lit with an LED light source. That's the requirement for indoor. Or you can have other energy sources. Some sensors require more energy because of the physics, how they are built. So they would be, the power would be wired, but you would never need to wire the communication path. So this is why adding those multitude of sensor types becomes easy once you have the digital ceiling made of Bluetooth NFC products.
We at the Bluetooth SIG have a vision of creating a better world through connection. Can you talk a little bit about how all of these solutions come together in service of that end goal? How is this helping create a better world?
The power of Bluetooth is that it is super efficient and very reliable the way it is fundamentally designed, but also offers this opportunity of designing a really great experience around this technology. And I think this is very important because there are only a few technologies that, they may be on the operational or performance level, may be similar, but they are difficult to implement and then they are difficult to use. And that creates a huge friction, and that limits your market, that limits your speed of adoption. Now, with Bluetooth, we have the best of both worlds. We have very reliable and scalable, efficient wireless communication system. But then we can also build a really phenomenal user experience around it. And these two together, those two, they create a winner.
If building owners, cities, or enterprises could really just take one step today toward becoming more sustainable, what would you encourage them to do first?
Install sensors. The road to sustainability, it leads through sensors. Different sensor types, you can consider these data points about maintenance, also sensor data points, because they measure energy, they measure voltage spikes. It's all sensing technologies. So installing sensors, pick your favorites. Wireless sensing, I think, like in a nutshell, this is all about wireless sensing in buildings.
Listen, hey, before I let you go, I actually came up with something specifically for you.
Sure, but I'm scared.
You should be. You should be. You know me well. Are you up for a bonus speed round of Would You Rather with a like a building systems and sustainability theme?
Sure.
Which feels more like you? The node, the controller, or the network itself? So the individual contributor, the thing coordinating activity, or the thing bringing everything together?
2 and 3, half and half somehow. So definitely I like helping organizing things, but also being part of the ecosystem is what I want to be.
What would you rather be? The luminaire, the sensor, or the control system?
Interesting question. Definitely, I don't aspire to be the control authority. The good thing is, though, with Bluetooth NFC, we have this concept of distributed control plane. So there's no single controller, there's no single control point. It's just collaboration, and we call it collective intelligence in some cases. So this is, if this part of control, then I want to be one of the nodes in this control plane, working with others.
Shared control.
Shared control, yeah.
In a built environment, would you rather know exactly what's happening right now or know what's going to break next week?
Definitely, I love being proactive about things. So if I have any insights that lead me to address things before they happen, absolutely, yeah. Having insights into the future, that's valuable.
Would you rather save 50% of a building's energy consumption or double the lifespan of every system inside it?
Why do I have to choose?
You can only pick one. That's the game.
No, we can do both. I mean, they are not exclusive. I mean, like we discussed for an hour how they can play together, and now you're saying that they are mutually exclusive.
Now
I
I'm
don't
making
agree
you
with you.
choose. You're right. Okay. I retract the question. All right. Well, Simon, thanks for indulging me. And again, thanks again for doing this. We appreciate, your time. And of course, we really appreciate all you've done to help advance the technologies and the standards that make these kinds of sustainability outcomes possible. So thank you. It's been great to chat.
Yeah, likewise. Thanks for having me. It's been a great discussion.